Thank you, Marilee. Good morning, everyone. Jeff and I are really happy to be presenting to you this morning, and we thank you for taking time out of your summer schedules. I'd also like to thank Marilee and OCLC Research for organizing this. So we're talking today about our Repository Analytics and Metrics Portal, or RAMP for short. And in a nutshell, RAMP is a web service that we developed that tries to address a problem that many of us have with our institutional repositories, and that is accurately counting file downloads from those IRs. You may have heard of at least one other project in the United Kingdom called IRIS UK that's also working on this and has been for several years. Our approach is just different, and so we are thrilled to bring it to you today. Okay, so this research was funded by a grant from the Institute of Museum and Library Services, and there are 4 partner institutions involved in this grant: Montana State University, where I work, OCLC Research, the Association of Research Libraries, and the University of New Mexico. And the title of our grant is Measuring Up, Assessing Accuracy of Reported Use and Impact of Digital Repositories. The original grant proposal can be viewed in Montana State University's institutional repository at that handle that you see on your screen. And RAMP is just one of the products that's come out of this research. So today, I'll just outline the agenda for you. We are going to start off by talking about a new reporting model that we would like to propose for counting use of institutional repositories. We'll move on to a brief description of the current reporting methods, both page tagging analytics services and log file analysis methods. Both of them have their own problems. Then we'll talk about a summary of our research findings and the method that we developed, and from that method, the web service RAMP sprang up, and Jeff is going to give you a demonstration of RAMP, and then he'll hand it back to me and we'll talk a little bit about the big picture potential, what we can do with the data that we're collecting through RAMP. So just a disclaimer here, or a caveat: we discovered a few days ago that there's actually another RAMP project at the University of Miami. Their RAMP project is called Remixing Archival Metadata Project. We just happened to choose the same acronym that they did some time ago, but we weren't aware of it until a few days ago. So just to be clear, the RAMP that we're talking about today is not the University of Miami's project. So let's start with a new reporting model that we're proposing. We like to divide up the pages that could be counted when a user visits an institutional repository. We like to divide that into 3 categories. The first are these ancillary pages, and we consider these rather low-value pages. They're simply HTML pages that users navigate or browse through when they go to the IR itself, when they land on the IR splash page and then start to move through. And these can be search results, they can be browse results, and so forth. The next category is the item summary pages. And these are also within the IR. These are also HTML pages, and we also consider them fairly low value. So they would be the page that you get to right before you see the actual publication. So they would include the title and abstract, some metadata, and that all-important link to the item. These two, the ancillary and item summary pages, are what Google Analytics is very good at counting. But again, we consider them to be low-value pages because they're not the item themselves. The real gold in an IR is what we call citable content downloads. These are non-HTML file types, usually PDFs, but they can also be presentation files, Word files, data sets, and so forth. And this is what you expect that people will cite during their research process, right? You want them to be able to download the item read it and then cite it in their own research. And so this is what we consider the high-value pages and what we really want to try to count in institutional repository use. So just to run through some examples, this is our own institutional repository at Montana State University. It's called ScholarWorks, and this is the splash page for it, and this is what we would consider an ancillary page. This is a set of search results within the IR, within ScholarWorks, and it's also an HTML page. It's also what we would consider an ancillary page. This is the item summary page. You can see there's the title of the article, the abstract, a little bit of metadata. You can reveal more metadata if you want to, and there's that important link to the item itself. This is also an HTML page. This is the item summary page. So moving on to current reporting methods, there are basically two types. The first is what we would call page tagging services. And this includes Google Analytics, Web Trends, some others. They're typically delivered as a software as a service. And they require a page tag embedded on each HTML page in the website. Okay? So all of those ancillary pages and the item summary pages would all have this JavaScript embedded in the HTML. When a user views that page, it acts as a beacon and sends a signal up to the server at Google or Web Trends and records that as a page view. Okay? It works great for HTML pages. The other method is log file analysis. And some software packages, IR platform packages like DSpace and ePrints, have log file analysis software built into them. The problem that we've found with log file analysis is it is heavily polluted by robot traffic. There's literature out there that says up to 85% of the traffic that is recorded as visiting institutional repositories is non-human robots or algorithms or crawlers, whatever you want to call them. So the problem with both of these classes of web analytics is that the page tagging services tend to dramatically undercount use of the institutional repository because they only count HTML pages well. The log file analysis tends to dramatically overcount use of the institutional repository because it's really difficult to filter out robots because they're constantly changing. So it takes a lot of resources to really keep up and manage a whitelist of visitors that can be filtered into the analytics rather than out. So just to show you where the rubber hits the road, if a user goes to Google Scholar and does a search and brings up a result like this, and they click on that PDF link over to the right, that takes them directly to the item in the institutional repository. It takes them directly to the citable content download and therefore bypasses all of that page tagging code that's on the HTML pages. Google Analytics cannot count a click on this link. Same thing if you're in Twitter and somebody clicks in the link that you provide, it again bypasses the HTML pages. So that, in a brief summary, is the real problem with Google Analytics and other page tagging services. They can't easily count these direct citable content downloads. So we learned, of course, about this in our research, that page tagging does not track non-HTML citable content downloads. However, Google has another product called the Google Search Console, which does count citable content downloads. So we developed a method based on Google Search Console, and we documented it in this paper. So just to show you some of the research that we did to arrive at these conclusions, we looked at 4 repositories in the spring of 2016, a 134-day period. 3 of those repositories were running DSpace, 1 was running Content DM. And we discovered that most of the IR activity goes unreported by Google Analytics. Okay? You can see each of those repositories there has at least 46 and as much as 58% of the traffic during that period was unreported by Google Analytics. And we did this simply by comparing the Google Analytics reports with what we were able to see with Google Search Console. The other thing we learned is that most of the IR activity is actually that high-quality, citable content downloads. And so, sort of a side point, one of the things that we've discovered is that if the repository has been optimized to work with Google Scholar, then Google Scholar itself drives more than 50% of the traffic to IR. So it's very worthwhile to make sure that the IR is working with Google Scholar. Okay, a little bit more data. This compares the ancillary and item summary page views from those 4 repositories with the citable content downloads. So the 2 columns that are highlighted at the moment, item summary page views and ancillary page views, this is what Google Analytics was able to capture from each of the repositories. And the 3rd column there, total Google Analytics HTML page views, just sums those first 2 columns. But again, the important stuff is over on the right side, the citable content downloads. This is everything that Google Analytics missed from that period. So these are the high-value downloads that we were able to track. Now you notice there's one more column there to the left called download events. Google Analytics does have the capability to count downloads from within the repository if download events have been turned on in Google Analytics. You can see that 2 of the repositories we looked at just didn't have it turned on at all. And the repositories that did have it turned on counted just a fraction of download events of the total that we were able to capture using Google Search Console. So all 4 of these institutional repositories used Google Analytics, and the important number is over on the right, 563,000 citable content downloads from all 4 repositories during that spring semester of 2016 were not being captured with Google Analytics. So it's a serious undercounting problem. And that improvement, that 563,000 downloads that we were able to show with Google Search Console is a 2,000% improvement in reporting. So there were some challenges with the method that we developed. The first is that because it's Google Search Console, it's only counting downloads that come from Google search properties. So Google Scholar, Google Images, and so forth. It's missing Yahoo, Bing, direct email, Facebook links, Twitter links, and so forth. However, the other thing that we've learned in our research is that the vast majority of traffic to institutional repositories is driven by Google properties. So we have every intention of building into our method the ability to capture non-Google properties, but we already know that it's a tiny amount. The other limitation is that Google Search Console itself limits time and access to the data. There's a moving 90-day window. And to do this required some programming skills. And that was really why we developed RAMP. But I'm going to pause here and see if there are any questions so far.
Yeah, so Kenning, I'm not seeing any questions. Oh, there is one question. Karen Smith-Yoshimura asks, does the Google Search Console count downloads from Twitter?
No. So it will not count non-Google properties. So
yeah, so not Facebook, not social media.
Exactly, not Yahoo, not Bing.
Right.
So that's the capability we still want to build into our method, but as I said, we already know from our research that it's going to be just a tiny addition of traffic.
Right. Okay, that's the only question I'm seeing right now, but I just want to encourage people, please get those questions. Oh, here's another question. Has anybody worked with Omeka and Google Analytics?
We have not. I don't know if anybody else has. It would be the same issue. Google Analytics would be very good at counting the HTML pages in Omeka, but not the non-HTML downloads.
Okay. Okay. So let's keep those questions rolling in. Let's keep going, and then we'll have another pause at the end for more questions. So
okay, so
let's resume.
Over to Jeff, and he's going to take you through RAMP, and he's just going to give me guidance on when to change the slides.
Great. Thanks so much, Kenny. Thanks, Marilee, for inviting us both to speak today. So Kenny gave a nice wrap up, our introduction as to the research that led up to this point. And as he mentioned on the last bullet of the previous slide, the research and the data we're gathering did require some programming skills to access the API, the Google Search Console API, as well as sort of collect and aggregate and analyze the data. So to sort of help streamline this process, we developed RAMP. Can you next slide, please? So just to go over the sort of the quick pertinence or facts about RAMP, it's a cloud-based web service, and as a result, there is no installation that's required. There's minimal training and configuration. In fact, the only training or configuration really needed is providing us, the hosting folks, with a bit of information about your IR, and then setting up on your Google Analytics settings, providing access to such that we can collect the data for you. The other advantage of it being a sort of cloud-based application that uses the standard Google Search Console API is that it provides a consistent method and terminology for analytics gathering. And this is very helpful if you're interested in doing benchmarking, not only across time, but more importantly, across organizations. Again, because there's this consistent method, there's no need to worry about whether organization A is using log file analysis versus organization B using web tagging analytics, or whether the robots.txts or robot lists are up to date. If two organizations are using log file analysis, this is something that is completely eliminated and sort of brought to, like I said, to a consistent methodology. Next slide, please. So most importantly, accessing RAMP, the URL at the top of the slides will take you to a landing page that will give you some more information, background information about RAMP, point you at some articles that have been published about the research and the prototype. And most importantly, at the bottom of the screen, there is a very distinct blue button that you can click on to get access to the application itself. When you click on that button, you will be prompted for an organizational access code, which we can provide you. Next slide, please. So assuming you have this access code, this will take you to the prototype landing page, and you'll see a large list of all the participating organizations. Kenny, if you could advance 2 more times, please. Excellent. And this is just some brief stats on who is currently using RAMP. Right as of June 20th of this year, we have 12 institutional repositories across 10 organizations participating in the pilot. We're currently tracking approximately 250,000 digital items, and we're capturing on average about 14,000 citable content downloads per day that were previously not being accounted for by Google Analytics. And finally, this is another advantage of this sort of cloud-based analytics tool is we're actually currently supporting 4 institutional repository application stacks. So we're working with DSpace, Fedora, bpress, and content VM. And this is not a all-inclusive list. This just happens to be the 4 from which we have participating IRs. And the most important thing about being suitable for using RAMP is really has nothing to do with about the IR application stack you're using, but most importantly, whether the application has an indicator in your URL pattern as to whether an item is being downloaded, a downloadable item, or whether it's an HTML page. And all 4 of the IRs that we've worked with all have very distinct tokens. So we're convinced that there would be no problem with other institutional application stacks participating in the pilot. Next slide, please. So from that landing page, if you're logged in, you do have access to any of the participating organizations' data. So, for example, even if I logged in as the University of New Mexico, I would be able to click on Montana State University's page, and what you then get prompted with is sort of a dashboard page that's divided into 2 or potentially 3 if you're an authorized user sections. The first of these sections is the daily statistics section. Here you can see the ubiquitous date picker. So for any date spanning back to the first day that the organization joined the pilot, you can do a variety of different visualizations. Next slide. The first visualization is just a sort of a simple access by device type pie chart. So it's divided into desktop, mobile, tablet. Next slide. The next visualization is a click comparison chart that will show you for the given date selected how many citable content downloads were triggered based on across all the organizations that were logging for that given day. And next slide. Advance one more time. And then the last option for the daily statistics is to download all the data. And here is an example of what this download will look like. It's a TSV, so you can open it up in your spreadsheet application of choice. And in it, I wanted to point out that we are logging in the data both citable content downloads as well as non-citable content downloads. And this will become important when Kenny talks about the feature potential of using the data we're collecting. But the other data points you can see that are being collected are the actual URL, the country of origin for the click. And on this topic, I did want to point out that we are not collecting nor sharing any personally identifying information. So the most granular data point we get from Google is the country of origin. So there's no IP addresses or anything like that we're even getting, and consequently cannot be sharing. So it is very secure for those concerned about personal identification security. And then the other information is more sort of tuned towards Google Search Console, like impressions, click-throughs, and then finally there's also clicks in the final column there. Next slide. So the second sort of section of the dashboard is a cumulative stats section. And here there are sort of just 2 default visualizations. There's this sort of a histogram chart that again, logging from the first day that the IR joined the pilot, how many clicks per day. You can see some interesting trends here. So this is for Montana State University. They started logging January 1st of 2017. And you can see that up until about February, March-ish, the counts are relatively low. And that's because at that point in time, Montana State University was on winter break. So it'd be assumed there are going to be obviously there are lower amount of traffic towards their IR. But you can also see on an almost consistent basis this week versus weekend sort of troughs and peaks and things like that, which is also very interesting. And this also will show you the average number of citable content downloads. Next slide, please. The other cumulative stat visualization we have is this sort of world map, sort of click by country statistic. That's why actually when we were looking at the daily stats, the country of origin was important. This is an interesting visualization tool. For some of the organizations, it actually highlighted some interesting, what we thought were oddities, but upon deeper investigation actually made sense. So for the University of New Mexico, for example, the clicks per country for almost all of the IRs, the United States was consistently the highest click per country, except for the Canadian organizations that are participating, in which case it was Canada, basically the country of origin for the university. But for the University of New Mexico, the highest click per country was actually from Ecuador, which we thought was relatively odd. So the IR manager at University of New Mexico, John Wheeler, did some investigative work and found out that one of the collections in the University of New Mexico's IR had to do with like a prominent like land survey report or something like that from Ecuador. And as a result, it is highly used by students, faculty, et cetera, of these various Ecuadorian universities. So again, it was something that a visualization like this would quickly show you, but if you had to sort of manually figure out this, figure out where things are coming from and who's using it, and that could be a relatively laborious process. Next slide. And then that final section I mentioned was dependent on whether you're an authorized user or not. If you are logged in and select your own organization, you're presented with just a simple organization settings dashboard. And the reason I throw this in here is I think it's a good sort of example of how simple it is to use RAMP. There's actually, after you've been hooked up, there's two settings. There's turning on and off daily logging, and then there is a portion to add or remove sites that you'd like the application to analyze. And this is, like I said, I think this is sort of an illustration of how simple RAMP is to set up and get started. Next slide. So at this point, I will turn it back over to Kenning to talk more about the big picture, what we want to do with the data, how it could be leveraged in future research. And then at the end of this section, we can have time for a question and answer, not only about the prototype itself, but also about this section Kenning is going to be speaking about.
Thanks, Jeff. So we think RAMP is a very accurate and very simple tool to use. But one of the most exciting things about it is the data that it is collecting. Since it is not individually installed at every institution, we are collecting all the data from all the institutions' visits and downloads to IRs in a central place, and that creates great potential for analyzing that data. So right off the top, Jeff showed you this chart, and this comparison provides an easy diagnosis. We can easily identify whether there are IR that are underperforming, usually due to SEO problems. So you can see there are two institutional repositories there, Maryland and WinSpace, that have little or no visitation or use. WinSpace, we know, was simply because they were just coming on through the onboarding process when the screenshot was taken. So that's not a fair assessment for them. But Maryland has been consistently low since we started logging with them. So this would be an opportunity to communicate with the managers of that repository and say, hey, there are probably some search engine optimization problems that you're having with your IR that are preventing Google and Google Scholar from harvesting and indexing the material that you have there. But the longer term potential for this data is pretty significant. Jeff showed you that URL, or that handle that Google Search Console gives us for every item that is either searched or downloaded. And this provides us with a great data mining opportunity. Again, there's zero personally identifiable information in here, but because we have this URL or this handle, we can use data mining techniques with the APIs from the repositories to go out and harvest information or metadata about each of those articles. Once we have that metadata, we can reconcile the key entry fields, basically normalize the data right across the fields. We can reconcile them with existing vocabularies like Library of Congress subject headings, VIAF, or FAST, and we can integrate that descriptive metadata with RAMP analytics data. Once we have enhanced the data, we can do things like this. We can start to evaluate the scholarly record across institutional repositories. We can review what it is that institutional repositories have. What's the content that most of them have? We can do a gap analysis between what is being searched and what is found. Jeff showed you on that spreadsheet sample that we are collecting both the citable content downloads and simply what was searched but not downloaded. So this allows us for a gap analysis. And then this, back to kind of a more advanced SEO issue, how visible are IR items in search engine results pages? So if you do a search in Google or Google Scholar, there's a difference between your item showing up on the first page and your item showing up on the page 20 or something. If it's pretty far down, most people are not going to get to it, and so there may be SEO techniques that can be used to raise the visibility in that search engine results page. And then longer term, the real high value of this is everybody wants to know how much impact are IRs having on the scholarly record. And so this provides us with a big step toward figuring out what time to citation is and the number of citations that articles get as a result of being in institutional repositories. So there's a lot of potential here for doing some collective research with the data. We want to make sure that this research data set stays open and accessible for anyone in our profession to use. So we have some, we talked about how there were some gaps in the method that we've developed, and so there's some more development that we want to do of RAMP. We want to expand the reporting and analysis capability, add more visualization and statistics features. We also want to be able to capture data from those non-Google providers. Even though we know already that it's not going to be a whole lot more information or a whole lot more citable content downloads, we still want to make sure that we close that gap and capture data from Bing, Yahoo, Facebook, Twitter, and whatever other social media platforms that we can. So this is our development team at MSU, OCLC Research, and the University of New Mexico. And then these are the publications that we've produced so far. I showed you the first one, Undercounting File Downloads from Institutional Repositories. There is a more specific publication about RAMP itself that appeared in Library High Tech a few months ago. And then once again, the original proposal that we submitted to IMLS is also available. So that concludes our presentation, and I'll turn it back over to Marilee, and we'd be happy to take questions.
Thanks. We have plenty of time for questions, and we have some, which is great, but we have time probably for some more. So if you've got those burning questions, please be typing them in. So John Novak from UNLV has two questions. One is, we use Digital Commons and are wondering if if that platform was included in your research and what you found. So any pilot participants using Digital Commons?
So as Jeff mentioned, RAMP is capable of capturing data from Digital Commons. I think we have one often that's using Digital Commons, and we're starting to capture data from them. Jeff, correct me if I'm wrong about that.
That is correct. We're in the final stages of getting their Google Analytics configurations hooked up. So I don't think we have any data from them as of today, but that is a platform that is, as of right now, supported out of the box, if you will.
Okay.
I would really, can I just say something else, Marilee? I would really
Sure.
encourage Digital Commons participants, because we know that bpress provides great statistics, download statistics to their customers. They are using the log file analysis method, and so it would be a great comparison of ramp data that's collected versus what they're providing their customers.
Well, that's perfect, because John has a second question, which is our university has both Content DM and Digital Commons. If we participated, can we track both separately?
Yes, you can. Yeah. So the way we handle multiple IRs in the prototype is either you have one profile that has multiple URLs for all of your institutional repositories. But in this instance, if you have two different platforms, what we've traditionally done is just set up two profiles. So when you're on the organizations list, you'd see one organization tab for, let's say, your Content DM IR, and then another tab for your bpress IR.
Okay, great. Let's see. Here was a question, is there a way to differentiate between HTML non-citable content and HTML citable content? So if an article is in HTML, is there a way to differentiate between the two of those?
So if, I guess this is sort of a yes and no answer. If that HTML document has within the URL pattern to get it a token to indicate that this is a downloaded thing. So if you were to download it, let's say, then yes. But if it's an HTML article that is simply a link within your website, then it would more than likely not have that token to indicate that this is an actual item in the repository and would not be counted as a citable content download. But I have not seen a lot of IRs that do not have the, that have item content that's simply an extension of the website. Most commonly I've seen, if you wanted to read the article, let's say you download it and it pulls it from whatever database the items within the IR are stored in.
Okay, so it sounds like Jeff would be a person to follow up with if there's more questions about that, or more specific, deeper look to take on that.
Just to follow up on that, if there are examples of that, I'd love to see them, because I'm sure something we could account for. It's just not something we've run into in the past.
Yeah. Okay, great. Here's another question that goes to kind of future development. Are there ways to feed the data collected back into the repository to display item stats to users?
Yeah, that's a really, really interesting question, and the answer is yes. So RAMP was built from a API-first approach. So all the data that's visualized or viewable in RAMP is driven by API calls that access the data that's stored in our Elasticsearch index. So for example, DSpace, its pages are derived from style sheets that make various calls out to the index or the data repository store. So what would be very feasible would be within that style sheet that generates the page, making a call out to our the API that delivers data to the RAMP application, and it could deliver back the exact same data to the institutional repository application itself.
Okay. So let's see. Here's a couple questions about RAMP. Is there a way to drill down to the item level? And can one retrieve data based on the author or item type? So for example, thesis or article.
Right now, that's not built into the system. But what we've been looking at, specifically what Patrick O'Brien has been looking at, is taking the handles that have download clicks associated with them and doing a data merge with the metadata for those items. So right now we're looking at this as being an offline process, but it's in principle, it would be very easy to take the citable content download URIs or URLs, pull out of them the item handle and the ID, and then use the handle IDs to do a merge with the metadata, and then what you would have as a result would be this thing was downloaded this many times, and here's the metadata for that thing.
Okay, great. So you could do some kind of more particular analysis on what types of things are being downloaded for. Let's see. Here's another question. Does IR staff have to set up the Google Search Console, or is that done by RAMP?
So that is the one bit of configuration that's needed. So you can actually activate Google Search Console through Google Analytics. So the one requirement is that the participating IRs have to have Google Analytics set up. And then within the Google Analytics settings, there is an option to create or authorize users. What the participating organization would have to do is go into Google Analytics settings and add 2 email addresses as restricted access users. The first of those email addresses is the username or the account for the RAMP prototype, and the second one is one that Patrick uses just to do any diagnostic, just to do any error checking, making sure things are running well on a regular basis. But that's something that the IR would have to do. But Patrick is really, really good at walking people through that.
Okay, great. I don't see any questions at the moment. I'm going to give people an opportunity to type any last questions that they have in. I have a question. Kenning and Jeff, you mentioned that you'd like to have some Digital Commons participants. Are there any other types of participants that you're particularly looking to include in the pilot, or I don't know, different characteristics that you wish you saw if some more representation from?
I don't know that I think in general we just want more participants so we can build this data set. And again, this data set will be available for anyone to analyze and conduct research with. So I don't think it's a particular type that we're looking for, just more.
Just more, right. Okay, so everybody is strongly urged to go to ramp.montana.edu and hit the button to join the pilot. Okay, we've got a couple more questions. Does the system have the capability to forward any item-specific or author-specific data to an author? I think that's sort of related to the question about can you display item-level stats?
So it does not have any ability to forward data to specific authors. What it could do is, if you did this sort of offline process, figure out how many times a specific article author was cited or downloaded, the university could certainly try to find that person. But one of the challenges with that approach, and Kenning and I and Patrick and others have looked at this in a previous grant, is because the metadata for institutional repository items can vary, especially with personal names, John Smith versus Jonathan Smith versus Smith, John. As the author, it's difficult based on the existing string data to know who the author is to send the information to.
Right. Okay. Here's one more question, going to, if you're wildly successful and everybody clicked on that join link, how scalable is RAMP? Are there any limits on the numbers of participants as you're currently configured?
I'm going to boldly say no. There are limitations. We have not run into any scalability issues as of yet, and we're actually, the machine that's hosting RAMP and the index is a relatively, not low power, but very standard sort of off-the-shelf system. So I'm not concerned about any scalability issues.
Okay. Here's a question about disambiguation and ORCID IDs. Would ORCID IDs help with that disambiguation that we're talking about?
That would be, yeah. I mean, if we could, if the metadata for the items had ORCID IDs in it, that would be the silver bullet for being able to provide author-specific citable content downloads to the appropriate person.
Right, but we're kind of living in a mixed environment where the metadata for the articles doesn't live in RAMP, it lives elsewhere.
That's correct. Yeah, this would all be an offline type of process. I think it falls into that last section that Kenny talked about, is the future research and what's the potential for this data.
Right, and what naturally lives where. So, okay, yeah, I think the answer is that identifiers are always good. Okay, I'm not seeing any other questions at this time. So I think I'm going to go ahead and thank our speakers very much. Also thank our incredibly engaged audience. You guys all showed up on a holiday week to learn more about institutional repositories and how to measure within institutional repositories. This webinar has been recorded, and we will make a copy available as well as the slides. So thank you all so much for participating today, and that concludes today's webinar. Thank you.
Thanks, everyone.
Thank you, everyone.
Bye.